X. So what I'm going to do is I'm going to start off with our credit cards. So I'm going to adapt our credit card class to be capable of being stored on Firebase. So I'm going to go into credit card. All right. Now, let me put something in our slides here. We have something called an interface. Okay, an interface is, let's say it is kind of like a class, but rather than having an implementation, it instead dictates what must be implemented.
So what's the difference between a user interface and an interface?
Well, a user interface is something you see. An interface is like a object-oriented. I mean, it's not visual at all. You'll see it here in a second. All right, so a good example of this is actually if you want to make your own threads in Java, you would do something called implement the runnable interface. And the runnable interface dictates that you must have a method called public void run. You have to write that method yourself. You're not extending the interface. You're not getting your own version of that method. By saying you're implementing that interface, you are promising whoever's using your class that you will have a method called public void run. You have to have it. It'll scream at you if you don't. Okay, so for example, if I come in here to my code and I just say implements runnable like this, highlight over this, it says this must either be declared abstract or implement the method run. All right, so if I come in here and I say public void run like that, now he's happy again, even though my function doesn't do anything.
So it's calling, the top one is calling runnable, which then
this just says I am abiding by the laws of runnable.
Oh, okay.
So when I implement runnable, I'm saying that this guy is a runnable class, which means that you can expect he will have a run method. Okay? We're not going to be using runnable right now. That's the reason I use that as the example is the interface we're actually going to use doesn't even require us to write anything. It's something that Java uses to give a type to this. So we're actually going to implement something called Serializable. All right. And so I'm going to introduce a couple of terms here. One thing you'll notice here is that in Java, most interfaces end in able, runnable, serializable. So if you see something that says somethingable, it's probably an interface. All right, so I was adding to the notes here. Working with data. Serializing an object means this is turning an object into a textual form. Probably JSON by today's standards. All right, so if we have an object and we want to turn it into the text version of itself, we'll probably convert it to JSON. Okay, that's serializing the data.
Quick stupid question. If it's a SOAP object, is it still serializing? A SOAP envelope?
Well, what do you mean? If it's a SOAP object, is it still serializing?
If you
Is what still serializing?
So anytime you turn an object into some sort of notation, representation thereof, it's serializing. So like if you're...
You mean if you're putting it in the form that for the SOAP standard rather than JSON?
Yes.
That technically is serialization.
Sorry.
Yeah.
That's what I was trying to say.
Yeah, you're just turning it into some textual format. Just the modern data representation we usually use is JSON because it works really well for
I have a
objects.
bunch of legacy systems that use SOAP. I'd much prefer to have them use JSON.
Yeah. the history there is that SOAP was the standard prior to our modern like RESTful APIs, and SOAP also bridged the gap. It was during the time of XML, but had their own kind of standard that most places didn't follow. But then when JSON took over, we just went with RESTful APIs that all speak JSON. XML is the current legacy. But since we're typically working with reading and writing objects, JSON's a real good fit because it's made for notating objects. All right, so serializing data means turning the object into a textual form. Deserializing, or anybody know the official, here I'll ask you, this is turning a textual form back into an object. Anybody know the historical computer science term for deserializing? Starts with an M. A.
Materializing.
R. S. Marshalling. So it's marshalling data. So we serialize it into textual format. We marshal it back into object format. But nobody says that anymore. It's serialize, deserialize. Okay? So in Java, Java has, you got this, has a serializable interface that tells Java you have set up your object in order to be serialized / deserialized. Okay, so still an interface, but instead of us being forced into implement certain methods or something like that, we're really promising Java that we've done the necessary steps to make sure that Java can easily serialize our data. All right, so I'm going to show you what that means. Because we would like Java to serialize our credit card object and be able to write it to Firebase. We would also like to be able to read in from Firebase and for Java to deserialize our object. Make sense? All right, so first thing I need to do is I need to make all my fields public. I'm doing it for credit card right now, and I'll take you most of the way there. Then you'll have to do it for the rest of credit card and all of loyalty program. All right, so I made all my fields public. We can still have our normal constructor here for this guy, but we must also have a no argument constructor, which we just happen to already have. All right, even though we don't even use this constructor anymore. But the reason why we have to have this constructor, so we're going to say no argument constructor required for deserialization. Because what happens is when we read the data back in from Firebase, when we read in JSON, what we end up doing is it creates a blank credit card object. Then it sets the public fields. So it'll say credit card C equals new credit card. Then C.name equals the name field of the JSON. C.start date equals the start date of the JSON. C.min spend equals the min spend of it. Does that make sense? That's the way it deserializes it. So it needs to have the ability to create a blank object, and then these guys need to be public so it can get those things. All right? So this doesn't actually have to do anything right now. I'm not calling upon this anymore. So this can literally just be a blank constructor. Okay? But it doesn't have to be. It just has to take no parameters. All right. So that's the starting point. Now, anything that we don't want to be part of what gets stored. In fact, actually, let me test this first because I think this will work as is. So what I'm going to do here, before I add any extra crap, I'm just going to leave it like this. I'm going to go into my main activity. And let's see, a credit card is name, start date, min spend, point bonus. So I'll go ahead and create a credit card. All right, this guy is going to have Chase, Sapphire, something like that. What are the other things? Start date, min spend, point bonus. All right, so I just created my instance of a credit card. And then I'll go ahead and I'll say myref.setValue to CC.
And you're storing the object?
Storing the whole object. All right, let me make sure this works first before I explain what's actually going on. So let me empty my database real quick. And actually, why don't I just move it to be a little bit more correct to, so why don't we call this guy credit cards. Call that guy credit card ref.
Should use the fancy refactor.
I actually could have. It's true. And then I'll have that, and then I'll say, just for the sake of right now, I'm going to say database reference. Myref is equal to database.getReference, blah. Just so this add event listener thing still works. All right. But then I'll set my credit card ref's value to that credit card. All right, so we're going to try to write a single credit card. So I created an instance of a credit card, and then I'm going to try to set the value in my database equal to that guy. So my database is currently empty. Go ahead and run this. So here's my credit card's endpoint. Here's inside here, here's a credit card. Minimum spend, Chase Sapphire, bonus points, start date.
Did you use the push method to generate?
I did not. If I use the push method, what would I see here?
You'd see your unique ID.
Some crazy ID thing, yep.
Is that something that you'll need to do if you
Absolutely, I'm gonna show it to you now, yeah. So right now, if I just keep writing credit cards, it's gonna overwrite the same endpoint. If I wanna have a collection of credit cards, so you're right where you need to be. So if I want to have a collection of credit cards, I am going to want to use push. So that will give me a unique credit card every single time I do this. A unique entry.
That's not what we want. Or that is what we
That is what we want. So here's my credit cards. So let's say you used your form and you entered one credit card. Here's your unique ID for that credit card. When I expand it, here's the information for that credit card.
That's really interesting the way that Google chose to do that. So is that like they said we're not going to use GUIDs, we're going to use something that kind of looks like a GUID, but isn't quite one?
Well, I don't know. I mean, this was how it worked before Google bought it.
Oh, okay.
So,
Whoever they, okay.
Yeah.
Sure.
so there I entered another one. So this is kind of like I, went to my add new credit card thing twice. Okay.
I have a question. When we get to going with this with the linked lists, and which maybe you're going to go to, like, does it make sense to like add it to the linked list first and then throw it into the database, or do it all at the same time? Because I know the node object has.
Here, so one thing you could do, it depends how reliant you are on the database. So best performance would probably be add to the linked list immediately, then write it to the database. Writing it to the database will keep trying it until it finally gets written, assuming it ever gets written. But then your local copy is ready to go. You can immediately update it because your list is showing what's in your linked list. The alternative way, if you want to maybe do it my internet connection's good and I want to do it, let's call it the probably not a good way, but cool kids might do it this way, is write it to the database and add it to your linked list as a result of the on changed. Yeah. So this guy will get called your on data changed, and then you could add it to your linked list when you've proven to yourself it was added to your database.
That's really going to frustrate the users when they have bad connectivity, though.
Let's just go off.
Yeah.
Is that the first time it's done that tonight?
We haven't been
Well, completely, it's been flickering, but.
Oh, interesting. I thought
eyes are going back.
thought that problem was solved. Okay, so now what I'm going to do is I'm going to go ahead and set this listener for my credit card reference. So I want to listen for things changing in there, okay? Now, the reason I want to show it to you this way, I mean, this makes sense as the ways we would probably add credit cards to our database, right? I have a kind of a database folder, and inside of that, I'll have a unique ID followed by the information about that database. A unique ID followed by the information for that database, or for that credit card, right? So every single time I have my form for adding a new credit card, I would fill in my 4 pieces of information, I'd hit submit, and it would write a new record to my database by doing a push, and then here's that stuff, okay? But when I go and read it in, we have to handle the data snapshots in a certain way. So I'm going to show you the JSON here in a second.
Is this still the same way we would do it if we have like hundreds of credit cards?
Yeah, I think so.
Or is there like a better organization?
I think this is probably, as long as they were all the same type of credit cards. I mean, if you had different types of credit cards, then you might have a separate subcategory. Maybe you have credit cards, Chase, Sapphire, Reserve, and then you have hundreds of credit cards that are all Sapphire, Reserve. So you might divide it up if you wanted to have it in there. But if you just want to have a big bucket of credit cards, this is fine.
And you can run like search things with the database?
Well, you can do some searches with this, or you could just write code that searches it yourself.
Well, that's kind of.
Yeah, so I mean, you have the control over it, so I would say real-time databases are kind of made for programmers. Yeah. All right, so now remember I said before that when you first set up your listener, it actually will just dump what the current database is out to you, right? So just for the sake of argument to keep these guys separate, I'm just going to change my data here a little bit. I'm going to change this guy to be Citibank, something, minimum spend, 2,000. Why can't I? I just made it so the object looked a little different than the other ones so we can see the difference on them. All right, so I'm going to come back into my code here. I'm not going to write that database, write the credit card to the database anymore. Okay? Instead, what I'm going to do is I will set up my listener. I want to know whenever something changes in the database, and this will get called the very first time I run the app too, giving me my current state of, in this case, the credit card's endpoint. Now, I'm just going to comment out that for right now. And what I'm going to do is I'm going to print out data snapshot. I'll just say data snapshot. It actually will call toString. I'll just do it so you feel better about it. So this should show me what that data snapshot looks like. All right. So I'll open up Logcat here. I'll go ahead and empty this guy out. I'll do my search on a bunch of asterisks. I'll run this, so I'm not writing anything new to the database, but this should give me a dump of what's currently in the database. Okay, so here's my data snapshot. So I have a key called credit cards. The value of that is a collection. Here's an ID. Inside that is my Chase Sapphire, my start date, my minimum spend, my point bonus. Here's my next ID. Inside that is the other card. Make sense? I need to be able to process through this in order to turn it into credit cards. But in order to do that, I actually need to get the data snapshots within data snapshots. So let me tell you how data snapshots work. So data snapshot is Firebase's way of representing endpoints within the database. So in our example right now, what we actually have, if I go back to this, is I have a top level data snapshot whose variable is called credit cards and whose value is a data snapshot. Okay, so let me show you that. So I'm going to go ahead and I'm going to say data snapshot the credit cards is equal to data snapshot dot get value. I think that should.
What's that mean when you put the parens, like
This?
class in front of that?
This is typecasting. So I'm saying I know that this dude is actually a data snapshot. So I'm going to treat him as a data snapshot even though the get value method gives you a generic object.
Okay.
I just happen to know this guy is a data snapshot. So then I'm going to show, actually let's do it as a separate line. So I'll show you the whole data snapshot. Then I'll show you just the credit cards portion of that. Clear that, run this again. Pretty sure that that value will come out as a data snapshot. Oh, I didn't run it. Crashing. It is crashing. So that does not come out as a data snapshot. So instead, I'm going to say data snapshot.get children. So that'll be a collection of data snapshots. Yeah, let me walk it that way. So I'm going to say for data snapshot ds in data snapshot.get children. So I'm going to write a for loop that'll go through all of the data snapshots. It'll be for credit cards. And then I'm going to print out ds.toString. But right before I do that, I'll go ahead and print out the original data snapshot so you can see the JSON before that. So here's the JSON of my entire database for credit cards. Then I'm telling you that that guy is a collection of data snapshots. So every single time we see a JSON object, that's a data snapshot. So I'm saying go through and get me my collection of those guys, and I'm going to show you that. So a data snapshot is a name value pair. So the top level is credit cards followed by my collection of data snapshots. My collection of data snapshots currently has 2 data snapshots in it. The first one is unique ID object, credit card object. My second one is unique ID credit card object. All right, so let me run this and I'll walk through it and show you what I mean by that. Should run this time. I thought I was going to be able to see the middle level by looking at the string of it. All right, so here is my top level data snapshot. The key is a credit card. The value is, this is a collection of data snapshots. Okay? Where the first one has a key, which is unique value, and the value is my credit card object. The second one is a key with a unique value, and the value is my other credit card object. Okay? When I go through this loop and I get all of the children of the top level data snapshot, when I go through here and I print out each of those data snapshots, notice that the first one, the key is my unique ID, the value is my object. The key is my unique ID, the value is my object. Make sense?
Will it follow all nesting you have? So if you had another level of nesting in there,
I would have to do it correctly.
okay.
Yeah, so a data snapshot is a key value pair. So if we want to kind of, this is a key value pair. So every single time we have a key value pair, that's a data snapshot. So our top level thing here, we have a single key, which is called credit cards, and the value is a collection of data snapshots. This is a key, this is a value. This is a key, this is a value. So it's comma delimited, that's a collection of stuff. Happens to be a collection of data snapshots. So when I come in here and I say, okay, I'm gonna write this for loop, I wanna go through all the children, all the things that are in my data snapshot, that top level one, all 2 things. I wanna get each of those individual data snapshots. So the first time through DS will be the first child. The second time through DS will be the second child. All right, and I'm gonna print out that guy's toString. All right, and that's showing me the JSON representation of each of those data snapshots. So the first one it printed out was the key value is this, the value is this JSON. The second one, the key value is this, the value is this JSON. That make sense? So now I want to get it into an object. Credit card CC is equal to, am I still creating my credit card CC up there? I am, so I'm going to name it something different. I'm going to call this guy temp CC. It actually wouldn't have conflicted. I just don't want to confuse you at all. All right, so I'm going to just create a local credit card object here. I'm going to set this guy equal to ds.getValue, and the type of value I'm going to get is creditcard.class. And then I'm going to prove that I was able to deserialize or marshal that guy back into a credit card by calling that guy's display method. And that's something we wrote several classes ago. That's our display method for credit cards, right? So it's true for us to say that if I can store a credit card up in the database, then I can read it back in from the database, advertising that this guy is following the format of creditcard.class. If I can then call his display method and it shows me what I expected it to show me, then I've successfully deserialized that data, right? So we'll go ahead and we'll dump this. We'll run this. My temp CC. Why didn't you print?
because you're ending with the asterisks?
I actually think that maybe my temp CC, my display does something different than it used to. Oh, it is, because I don't have the asterisks. Yep. It's only here. We'll just do this. Throw some asterisks in front of it. Now it'll show up. Where'd it go? All right, there we go. So that looks like it's deserialized back into objects. This guy's deserialized back into objects. Could we do something like, let's take it one step further. Now, right now, my code, why does it keep doing that? It keeps doing the crazy zoom thing. Initially, my linked list has nothing in it, correct?
So now when you make something, it will be saved to the database?
Well, we're not saving it yet, but it would be nice if they did get saved.
So that's what I'm saying.
And retrieve it. But I'm going to show you the retrieving thing because I've already put 2 sample things up there.
So right now you're just hard coding it? Is that what you're saying?
Yeah, right now I forced 2 objects into the database, right, with a push. And I have that code currently commented out inside of main activity. So I created a credit card, I wrote it to the database. So this will write to the database.
Can you only write to the database within the main activity?
Right, anywhere you have access to the reference. This database reference right here. So if you happen to put that in core, you could access it from a bunch of places.
But that's not good? Or that's
Sure it is. If you want to write from, if you want to write to credit cards, anywhere you have credit card ref, you might put that in core.
Okay, so for the homework, put it in core. Stuff fine.
All right, so create credit card and store in Firebase. Maybe move this to core. Hint, hint. Something like that. All right. Then in here, I want to see what my core currently do. I have add credit card. Okay, so I'll just call my core's add credit card. Where's my main activity? All right, so now I'll read in my data snapshot for all my credit cards. I will go through all of the cards that I just found. I'll read in the card, so this is deserializing it, right? This is deserialize the card. Then I'll tell core to add that credit card. And what does that do? Adds it to the end of my linked list, tells my data set it's changed. So before, when we ran our program would show nothing cards initially, right? But now we have a list of 2 things in our credit cards. So there's our 2 credit cards that I just read from the database. All right, so do we understand how to write to the database? All right, so let's,
Push thing? With the
push thing. So here, I'll spell out the assignment a little bit. All right, so assignment. Make loyalty program serializable like we have for credit card. All right, step 1. What does that mean? It says make everything public and have a no argument constructor. That no argument constructor is used for the deserialization. Okay, because when I read it back in from the database, what it did is it just created me an empty credit card and then set the 4 public fields directly. Okay? All right, so that'll make your objects both compatible with the database. Make database references for credit cards and loyalty programs. So you have places to write to and read from for your 2 different kinds of objects, credit cards and loyalty programs. Okay? Set up listeners for both of those references, so you are notified of changes to credit cards as well as loyalty programs. Initially, populate your list views with credit cards and loyalty programs that may already be in the database. As new credit cards or loyalty programs are added, make sure they are stored in the database and update your list views. I'll say you can update them locally or rely on the change listener to be notified about the change to the database and let it update it that way. It's kind of a choice.
You spelled new wrong.
Spell who what?
New wrong.
New.
As need credit card.
Where?
Right there.
All right. Does that make sense? So when all is said and done, your app should be able to write loyalty programs and credit cards to the database. It should be able to, when you close your app and relaunch it, it should bring all existing credit cards back in, all existing loyalty programs back in because they're stored in the database. I guess that's it. You can't remove stuff yet. So not too bad. I guess what I should do above here is connect your app to Firebase. All right, so let me. No. But my current code?
Database stuff is actually stuff that makes sense. It was the first thing we did with the new layout thing that I didn't get.
Do you get it now?
Hmm?
Do you get it now? Or still not?
No, I meant like.
Talking about the loyalty program layout design.
Yeah.
Where we got like
I'm pretty sure you already pushed that because someone else asked for it.
Yeah, I pushed it at the end of the previous break. Firebase stuff.
repositories confused. Well, actually, I'm confused. I'm sure I get repositories fine.
All right, so there's that. And then assignment up. All right, so there are any questions about the assignment? Any information you want I can give you to push you in the right direction? I wouldn't think this should take any more than 60 or 70 hours.
Excellent. Yeah, I can do that.
Got another like 100 hours between now and next week, and I'm doing school, so 160 hours is a good rule, right?
Yeah, it's like a non-issue.
Yeah.
Gotta redo my upgrade now that I got rid of my bad variable. So I'll be sitting there watching the progress bar go from left to right.
I'm trying to push a database, right?
That's right. I don't know. The snob DBA and he was like, I don't know if I call this a database. Oh, sure, why not?
What are you doing right now?
Hmm?
What are you doing right now?
Pasting the, well, that doesn't look good at all. Here, I'm going to do this.
It's a JSON object. Just gotta put some curly braces around it. Deserialize your homework assignment.
Firebase.
It looks like you haven't set up any BoomKit accessories. You can connect smart devices like lights, logs, and thermostats in the home app.
All right, so this was good stuff.
Thanks, Siri.
Helpful.
Australian Siri. I tried the British guy, but he sounded too snobbish to me. Didn't like the American guy, it was too boring.
So mine's not pushing to the Firebase. I did
Yeah.
everything except